Hello. Alright, today I'm going to go over power series and its radius and interval of convergence. And let's see, I'm going to go over some definitions and theorems. And in the next videos, I'm going to do probably some examples. And if you do need any example that you want me to do particularly, you want me to make a video, please comment and I'll be happy to do so. So if we have a sequence, suppose the sequence looks in this form, it's listed right here. This function is called or known as power series. So in other words, a power series, so we want to see how can we write it in a shortcut instead of writing it all the times, in X can be viewed as a function with respect to X, of course. So function of X. So I can write it as f of X equals the summation, because that's what series means, where n goes from 0 to infinity, for some a sub n times x minus c to the power of n, centered at a point called C. So I'm going to say centered at X equals C. So going from here, let's start with the theorem. So the first theorem that we are interested in right here is this: convergence of power series. So let's take a look at how do I know that a power series converges. So we're going to see these are the criteria that you need in order for you to decide and make a decision that the power series converges. So number one, for a power series centered, again you need to know if it is centered at what? Centered at X equals C. Precisely, exactly, just one of these can be true. Not all, but one. So these things can happen. Number one, you will say that the series, so that's the summation of whatever that you see in the summation there, the series converges. Where does it converge? At C only. Or the other thing can happen. There exists a real number, and we're going to call it R greater than 0. So it has to be a real number such that the series converges absolutely. So take a look at my series videos, what it means to converge series and sequence. Absolute convergence. So converges absolutely for, so absolute value of x minus c less than r, and diverges when or for x minus c is greater than r. So we'll figure out what is this R shortly. Okay. And number three, if these two don't happen, the third one is going to happen. The series converges absolutely as well. But in this case, it's going to converge absolutely for all x. So three cases. One, it only converges at x equals c. One is it has a limit between c and negative c, and r and negative r, and the series absolutely, where r is the radius of convergence. So in this case, we need to know what's the radius of convergence n. So for case 1, where the series converges only at C, the radius R is equals 0. So this converges at x equals c is just at 1 point. For the case 2, where you have there exists a real number r greater than 0 where it converges absolutely, then the radius of convergence is going to be r. Well, you got to figure that out. And this is going to happen between, so you're going to have c right here, and this is going to be radius of convergence, either from the left or from the right. For the first one, it's just going to be 1 point. And for the case 3, where it's for all x values, so you have all x values, and you have c centered at c, the radius r is going to be infinity. So these are the main 3 things that you want to know. What happens when it converges, what's the radius, what's the interval of convergence. So these are interval of convergence and radius. So it's not too hard, right? But the hard part will come when you are trying to actually figure out how do I find the convergence? How do I find the interval? How do I find the radius? So let's take a look at, since actually this is a very short theorem, not many theorems involved in this chapter, we can absolutely take a look at an example. So let's see an example. I write G, E, G as an example. So suppose you want to find radius of convergence for this series. So this is n factorial, x to the power of n, as n goes from 0 to infinity. And you want to find the radius of convergence, and the radius of convergence is ROC. So we're going to find the radius of convergence. So when you look at it, we can see that this looks, of course, it is a power series, right? Power series centered at where? X minus nothing means centered at 0. So I can write this as a function. So the steps on how can I find interval of convergence and radius of convergence, there are some steps that I need to do. So first of all, I want to know how to find ratio test. How do I do ratio test? So if you recall from my past videos on sequences and convergence test, we can do a ratio test where if the sequence is a sub n, we'll do a sub n over a sub n plus 1 over a sub n and find the limit. So as simple as that. So here what I can say is I'm going to let a sub n be equals n factorial times x n. So what is a sub n plus 1? So quickly, a sub n plus 1 is n plus 1 factorial times x to the n. So what do I need is now I need to find the limit as n approaches infinity for a sub n plus 1 over a sub n. And then when we do the math here, the limit as n approaches infinity, absolute value of a sub n plus 1 is n plus 1 factorial. And when I expand that, that is going to be n plus 1 times n factorial. And I forgot to do a plus 1 here, times x to the n plus 1. And the whole thing over a sub n, which is n factorial times x to the n. So if we notice on the top part of this fraction, n factorial and n factorial gets cancelled, and n, x to the n and x to the n gets cancelled. So the only thing that's left behind for this absolute value is, let's continue writing, is limit as n approaches infinity. So we simplified, that's just algebra. This is going to be n plus 1 over n times x. So what we can do is, if you notice, we're just going to try to take a limit as n approaches infinity, which means x doesn't have any bearing on n. So we can pull x out, so that's going to be absolute value of x, and then you take the limit as n goes to infinity, and you're going to find the limit of n plus, I do not have an n at the bottom, right? Look, I can make a mistake here, but that's okay. So I'm going to delete that. There is no fraction, it's just n plus 1. Sorry about that. That's what happens when I try to do math on the spot. So this will be absolute value, or in this case, you know, absolute value of n plus 1 is just n plus 1. So what is the limit of this as n approaches infinity? This is going to be infinity. So in my case, by ratio test, you can see that is going to be your radius. What did it say? This is at x equals 0. That's centered at 0. We will say that the series diverges for x greater than 0, and it only converges at x equals 0. So here it only converges at x equals 0. So what this means is, what is the radius of convergence? Basically, radius of convergence for this is r. So that is a little hint that I would like to let you know. So anytime when you find a limit using the ratio test, a sub n plus 1 over a sub n, and you end up getting a solution here. So let's say you have a limit here, and of course you're going to have, in this case, you have a limit times absolute value x. This is pertaining in particular example right here. We can just say that the radius is 1 over L. So in this case, you have to take the limit as L goes to infinity, because infinity is just a dummy variable, right? Therefore, your radius is 0, and that's how you get radius as 0. Alright, this is just how you want to apply the theorem and the definitions of convergence, how to find the convergence of a power series, and probably in the other videos I'm going to work on how to find interval of convergence and radius of convergence, maybe going over several more difficult examples. And let me know if you need any more examples, any particular examples in the comment below. Thank you for watching.